This is Algebra 1, Lesson 6.4, and it keeps going. I'm going to try to get to all the way to 6.8 and finish this chapter. So I'm kind of combining several lessons in one. As you'll see, I'll give you, finish with one, and then give you some questions, and then continue with the other, the next lesson. This picture here is a picture of a mountain, and it's talking about the types of planet life on a mountain depend on the elevation of the mountain. Lower elevations you would see trees. At higher elevations you'll see flowering plants but no trees. And at very, very high elevations you're not going to see anything. No trees, no flowering plants. And so there's a couple of questions in this lesson on plant life on a mountain. So the first thing we're going to address is and, in reference to compound inequalities. And a compound inequality consists of two inequalities connected by, obviously, what? The word and. But it also could be connected with the word or. So the first I'm going to do is we'll talk about and then we'll talk about using or. In this case, it's asking you to write a compound inequality that represents the set of all real numbers greater than or equal to 0 and less than 4. Now this should be underlined right here, greater than or equal to, and less than 4. So you have one set here and you have one set, a little bit on the other side. So that's why the and. It could be numbers in one set and numbers from another set. So here the set can be represented by two inequalities. O is less than or equal to x, and x is less than 4. That's what it was talking about here. The two inequalities can then be combined in a single inequality. Oh, sorry, my screen. Where you would say 0 is less than or equal to x, which is also less than 4. So that's how you put them together, but you can have the word and there. You would verbally read the compound inequality in one of two ways. X is greater than or equal to 0, and x is less than 4. And then here is the graph. We would have less than, so x is greater than or equal to 0 but less than 4 is what this demonstrates. Now it's set up here two ways. And so the other thing that you can do, if you read x is up here, x is greater than or equal to 0, it doesn't look like 0, it looks like a pair, and x is less than 4. We could remove the x and just not say it, and then we would be left with saying x is greater than or equal to 0 and is less than 4. So whether you put the x there, say, actually use the word x, you can, or you can leave the x itself off. That's the two ways. Looking at the checkpoint that appears on page 342. We are given this example: negative 2 is less than y, which is less than 0. And you're being asked to write it, to put it into a verbal sentence. And so the verbal sentence, the words that we would use for this is y is greater than negative 2 and less than 0. Another example is 7 is less than or equal to t, which is less than 8. T is greater than or equal to 7 and less than 8 is how we would say that. And then another example, 4 is less than or equal to n, which is less than 1. We would say n is greater than or equal to 11. Oh, I wrote it wrong up here. I did put the 11, just had 1 there. Okay, so that's how you take the sentence and you put it using words. Now, solving compound inequalities that use the word and is just like basically solving anything else. We have negative 2 is less than x, plus, that represents the and there. This right here, this is a plus sign, represents the and. Negative 2 is less than x, and 2 is less than or equal to 4. And so the first thing we would do is solve these two separately. We're going to split them up. So we would have the, right here in the middle. So you're going to have, and then we're going to add, whatever you do to one side, you have to do to the other side. So let me get a different color here. So I've split up, I have one part there, and I'm going to have one part over here. But when I did that, it covered up. Hang on. There's one. There's one. So the original here, we're going to add, the first thing we're going to do, we're going to look at each part separately, and then the first thing we're going to do is subtract negative 2 from both sides. So I subtract, so the part that we're going to work with is going to be right here. So we have, what I've done is I've reversed this right here. So I have x plus 2. I wrote that right here. I switched my sign and put my negative 2 here. So here I had negative 2 is less than x plus 2. I switched it up to say x plus 2 is greater than negative 2. It's the same thing, I just changed the order. And then the second part of the sentence, which is right here, is x plus 2 is less than or equal to 4. I didn't change that. I kept that in the same order as what was right here. So this middle part is repeating for both of them when I split it up. If you're not getting this, holler at me so I can explain it because it's kind of confusing. So I'm going to subtract negative 2 from both sides. So I would have x plus 2, and I have to subtract negative 2 from this part of it, and from this part of it, from this part of it, and from this part of it. So each one of these equations has to be treated, both sides of the equation, of the inequalities have to be, you have to do the same thing too, and both sides. So this is one side, this is the other side, and we have to do the same thing here, same thing here, same thing here, and same thing here. So I'm going to subtract negative 2 4 times, and then I'm going to be left with, when I subtract negative 2 from x plus 2, I'm left with x. And then when I subtract negative 2 from negative 2, I end up with negative 4. My and is right here. Over here, x plus 2 minus x, minus 2 is going to leave me with x is less than or equal to, and over here I did 4 minus 2, and that leaves me with 2. So I have this side, my and this side. And this part we've done basically twice. So we treated this half of the equation, and we worked it out, and then we did this part of the equation. Then the answer is negative 4 is less than x, which is less than or equal to 2. Or there's another way you could do it. There's two ways to do this. So the first one solved the two parts separately. It broke it into two parts. This method is where you isolate the variable between the inequality symbols. So it's the same equation here. We have negative 2 is less than x plus 2 less than or equal to 4. That's the original thing that we just did on the screen before with the other method. And it says to perform any operation on a compound inequality with the word and, you must perform the operation on all three expressions. So we already talked about whatever you do, you have to do it to all the parts. So here that we have the original equation, which was here. It's down here. We're going to once again subtract 2 from each side. This time we're not going to divide it in half. We're just going to do it to the three parts. So we have part 1, part 2, and part 3. We subtract 2, subtract 2, subtract 2, and we end up with negative 4. Negative 2 minus negative 2 is negative 4. Is less than. We have x here. The negative 2 canceled out the 2 here, and then the negative 2 from 4, that's not right, that should not be a negative there. Let me take that off, sorry. So then our answer is negative 4 is less than x, which is less than or equal to 2, which is the same thing we got on method 1. So there's two ways to do it, whichever one is easier. And then whichever way we decide to do, the solution is going to be all real numbers greater than 4, or greater than negative 4, and less than or equal to 2. And so this is how we would graph that. So the first part of your assignment, so for lesson 6.4, the part 1 of this assignment is to do numbers 29 through 38 on page 346. And then after you do that, then continue with the next part of this lesson. So now we're going to talk about solving multi-step compound inequalities. And the first thing that we're given, the first is negative 3 is less than or equal to 2x plus, and 1 is less than or equal to 5. This is example 4 on page 344. So I rewrite my equation. In this case, I am simply going to just subtract, do the same thing to each of the three parts. Part 1, part 2, and part 3. So I'm going to subtract negative 1 negative in this, using method 2, what we want to do is isolate the x in the middle. Negative 1, I subtract negative 1 and subtract negative 1. That leaves me with the green part here, which negative 3 minus negative 1 is negative 4. Negative 2x plus 1 minus 1 is going to leave me with just 2x. And the 5 minus 1 is going to leave me with 4. Next I'm going to divide by 2, so I have to do it to all three sections. So I divide negative 4 by 2, negative 2x by 2, and 4 by 2. Now I need to simplify, and I end up with negative 2. The x is isolated in the middle, and a 2 here. And we've isolated the x between the two inequalities. This shows how you would graph this, because our solution was negative 2 is less than or equal to x, which is less than or equal to 2. And so the answer is going to be, this is how we would graph that solution there. So the next part of this assignment is assignment part 2 is to do the exercise numbers 35 through 38. And on page 346. But you're going to remember that when you multiply or divide an expression of a compound inequality by a negative number, you have to reverse the sign. You have to reverse both inequalities on that. So our equation here is negative 2 is less than negative 2 minus x, which is less than 1. So we got three parts here. I rewrote it here in black. So the next step is in orange. We're going to add 2 to all three parts. We're going to add positive 2 to negative 2. That's going to give us 0. We're going to add plus 2 to negative 2. That will cancel out the 2's and just leave the negative x, which is right here. And then 1 plus 2 is 3. So in the red here, we've simplified. Now we have to multiply by negative 1 and reverse the inequalities. So I put the inequalities in green. I have reversed them. And then I multiplied in parentheses by negative 1 in all three sections. I end up with 0 minus multiplying by negative 1 is 0. Negative x times negative 1 is going to be a positive x, and 3 times negative 1 is negative 3. And so our solution then is 0 is greater than x, which is greater than negative 3, and then here's my negative 3 to 0, where my, that's how I graph this right here. Your assignment, part 3, is to do exercises 39 through 46 on page 346. So now we're going to talk about lesson 6.5, which is using or instead of and, but or. And this picture here is about catching a pop fly and how you can practice on your own. You could throw the ball straight up into the air, and as the ball rises, the velocity gradually decreases until it reaches like its highest point, as high as it's going to go, and then the ball will turn around and start falling. And as it falls, the velocity increases. And so there's some examples in this chapter that talk about solving a compound inequality dealing with velocity of a baseball. So this is just an example of how math applies and can be used for different things. So we're being asked here to use or. So the directions are: write a compound inequality that represents the set of all real numbers less than -1 or greater than 2. Graph the inequality. So here is, I wrote it out, x is less than -1, or x can be greater than 2. And I graphed it down here so you can see that the x is greater than 2 part is right here, and the x is less than -1 is here. And so we have 2 parts to graphing this equation, this inequality. So checkpoint 4 on page 348 gives us x is less than or equal to -3, or x is greater than 0. And so I could write out, I could say all real numbers less than 3. It should be less than -3. Sorry, less than 3 or greater than 0. Sorry, I was looking at it the wrong problem when I said -3. It's just 3. And so here, to write it out, we have x is less than 3, numbers less than 3, or greater than 0, and I wrote 6 there. Boy, I didn't do so good here. This which should be 0. So your assignment number 4 is on page 351, and do exercises 11 through 20. So next we want to look at how you would solve a compound inequality with or. And so we have our x minus 4 is less than or equal to 3, or 2x is greater than 18. So we have to isolate the x in the middle, so we're going to have to get rid of everything but just this x. So the first thing we're going to do is we don't have to do the same thing to each side in this case. So over here we're going to get rid of the 4 so that we have the x isolated here. So we have, this would be plus 4 and plus 4. I have to do the same thing to both sides of this inequality though, but I don't have to do the same thing here and here, unlike when I did the and compound inequalities. So this will leave us with just x here, and 3 plus 4 is 7. So x is less than or equal to 7, or, and over here I'm going to divide by 2 so I can isolate the x, and 2x divided by 2 will leave x, and 8 divided by 2, oh this should be, oh that's 18, sorry. 18 divided by 2 is 9, and then that's simplified, and then I wrote it out here. We have x is greater than 9, or x is equal to or less than 7. So your assignment, part 5, is to do exercises 21 through 30 on page 351. So now we're going to solve and graph. So we have 3x plus 1 is less than 4, or 2x minus 5 is greater than 7. So our goal again is to isolate the x on each side here. So I'm going to subtract 1 from this, so that'll leave me with 3x, and negative 1 from 4 will leave me with 3. On the other part, I'm going to divide 2x by 2, and, oh, sorry, I jumped ahead. I'm going to do 2x minus 5 plus 5, so that will just leave me the 2x, and 7 plus 5 is 12. Now, on this side, I'm going to divide by 3 to isolate the x, so I will just end up with x. 3 divided by 3 is 1, so I end up with x is less than 1. Or, over here I divided by 2, so 2x divided by 2 is greater than 12 divided by 2. And then once I simplify that, I have, again, x is less than 1 or x is greater than 6. Now I can graph the two parts, x is less than 1 or x is greater than 6. And so this is x is greater than 6, and this is x is less than 1. And assignment 6, which is on page 351, starts off, is going to be exercises 31 through 40, and I'm going to head, I told you I was going to go through lesson through 6.8, but I think I'm just going to go ahead and stop here with 6.4 and 6.5 combined this time.